Hi students, today in this video we are going to discuss a small topic that is called mole concept. This topic is there in 9th class chemistry in our regular syllabus. Of course, you can see the same topic even in the case of CBSE textbook also. The topic was introduced by Wilhelm Ostwald. The scientist name is Ostwald generally. Here I have a doubt. That is, I have a pile of sand. Means a handful of sand is there with me. Can you calculate how many atoms are there in that sand? Yeah. And a handful of wheat flour is there. Or rice duff is there. Can you calculate how many atoms are there in that? It's not possible. Why? Because large number of atoms are present. So, to represent the large number of atoms in physics, we are going to use the powers of 10. 10 power 1, 10 square, 10 3, 10 power 4, 10 power 6 like that. But in chemistry, some new kind of the concept is required. For example, there is 18 grams of water. Sir, why you consider 18 grams of water? That is nothing but 1 unit of means molecular weight of water is 18. Why? Because 3 atoms of hydrogen is 2, 1 atom of oxygen is 16. So totally it is 18 grams. So 18 grams of water, that is nothing but 1 molecule, having how many atoms? That we require. Why should we count atoms? Why? Because every molecule is made up of atoms only, absolutely. And again, if we consider hydrochloric acid, HCl generally we may say, its molecular weight is 36.5. Why? 1 atom of hydrogen is 1 and chlorine, that is 5.5. By adding both, we can get 36.5. Now, how many atoms are there in the 1 molecule of HCl? Large number of atoms are there. To calculate the such kind of the large number of atoms, Ostwald introduced a new kinds of concept in chemistry. That is nothing but mole concept. The concept of mole, if you observe here, in Latin, mole means heap or pile. Heap is nothing but, for example, say there is a group of atoms. Group of atoms like a heap, like a sand heap and all. Means certain group of atoms, certain number of atoms, we can consider that as a mole. What is that mole indicating? It is indicating the large number of atoms or molecules that considered in a constrained volume. Constrained volume means fixed volume. For example, oxygen is there. 1 atom of oxygen means 16 grams of oxygen. 1 molecule of oxygen, 32 grams of oxygen. Why? Because always every element or every atom has its molecular weight and as well as atomic weight. If it is a formula, it has a formula weight. So in that particular quantity, how many atoms are there that can be expressed in the form of mole? This means we are expressing that quantity in the form of a number. So mole is a number quantity. It is used to express the large number of atoms or molecules. Now see the definition. Every concept compulsory must consist of a definition. The definition is the amount of substance which contain as many particles which is equal to the atoms present in the 12 grams of C12 isotope. 12 grams of C12 isotope means we are taking C12 isotope as a constant to compare the given values. Means how many atoms are there in the C12 isotope? Same number of atoms of the another substance can be considered as 1 mole. Number of atoms that present in the C12 isotope considered as 1 mole Why? Because C12 isotope is a constant isotope when compared to C14. Why? Because every body is considered with the carbon 12. For that purpose, we are considering C12. So, the how many number of atoms are there in the C12 isotope? Same number of atoms are present in the another substance or otherwise another atom or otherwise another molecule. That number is considered as 1 mole. Then how many atoms are there in the C12 isotope? There are 6.022 into 10 power 23 atoms or particles or molecules are present in C12 isotope. How they discovered? By using Raman spectroscopic methods and NMR spectroscopic methods, they discovered every C12 isotope which gives a mass of 12 grams contain 6.022 into 10 power 23 atoms or otherwise molecules. These 6.022 into 10 power 23 atoms or molecules or particles is considered as 1 mole. Means in 1 mole of atom, how many atoms are present? 6.022 into 10 power 23. Either atoms or particles or molecules are present. William Oswald given this number on behalf of his guide teacher, that is Avogadro. So Avogadro is an Italian. He is a teacher. So this number that we are calling 6.022 into 10 power 23 atoms or otherwise particles is called Avogadro number or otherwise Avogadro constant. These many particles are called Avogadro number. Let us discuss some of the particle examples which are present in this topic. In the textbook 9th class regular textbook also they given about this topic. Under some of the page number 70 of the textbook. Let us discuss some examples what that is present in this case. Now let us discuss mole concept regarding the atoms. For example, I am considering 1 gram of hydrogen atom. Why 1 gram? Why? Because the atomic weight of hydrogen is 1. So 1 gram of hydrogen atom contains 6.022 into 10 power 23. Here atom is came. So here also it becomes atoms of hydrogen. This is nothing but 1 mole. 1 mole of hydrogen atom. Now, one more example I am going to take. 16 grams of oxygen atom. Why? Atomic weight of oxygen is 16. So, 16 grams of oxygen atom contain 6.2022 into 10 power 23 atoms of oxygen. That is only the difference. That is nothing but 1 mole of oxygen atom. Did you understand what is the difference? Here 1 gram of, that is nothing but molecular weight of hydrogen is 1. So further its weight is 1. Now like that only in the case of nitrogen, if we consider 14 grams of nitrogen atom. Sir, why you consider 14 grams? Why? Because the atomic weight of nitrogen general representation is N714. How many atoms are there? Avogadro number only. That is 6.022 into 10 power 23 atoms of nitrogen. These 6.022 into atoms of nitrogen is nothing but 1 mole of nitrogen atom. 1 mole of nitrogen atom. Comes to the example of fluorine. Fluorine general representation is F919. So it contains 19 grams of fluorine atom. 19 grams of fluorine atom implies how many atoms are there? 6.022 into 10 power 23. atoms of fluorine is equal to how much? 1 mole of fluorine atoms. What does it mean? If you taken 1 mole of fluorine atoms, in that how many atoms are there? 6.022 into 10 power 23 atoms are there. That weight of 6.022 into 10 power 23 grams is nothing but 19 grams. If we consider in the case of sodium, general representation of sodium is what? 11Na23. That means 23 grams of sodium. This is nothing but atom. Contain same number does not change. 6.022 into 10 power 23 atoms of sodium is nothing but Na. This is nothing but 1 mole of Na atoms. Like that only we can take different kinds of examples. For example, I am going to consider one more, next one, magnesium. 12 Mg, 24. So 24 grams of Mg atoms. How many particles are there in that? Avogadro number only. 6.022 into 10 power 23. What that is? Atoms of Mg. This can be considered as 1 mole of Mg atoms. These are all the different kinds of examples regarding the atoms. In the nature, not only atoms, molecules are also there. Let us discuss what are the examples in the case of molecules. Now discuss mole concept regarding molecule. Example 1. If we consider one molecule of hydrogen, it is represented as what? H2. Now, one molecule of hydrogen, one atom is 1 plus 1, that it becomes 2. This means it contains 2 grams. Means the weight of one molecule of hydrogen is 2 grams. Then, how many particles are present? Avogadro number only 6.022 into 10 power 23. In the before case we wrote atoms. Now in this case we should write molecules. That's it. Nothing is there. Molecules of H2. Before it is atom. So H. Now it is molecule H2. Now one more example, if you consider one molecule of O2 means oxygen. O2 means nothing but one molecule. Single atom, its atomic weight is 16. Then two atoms, it becomes atomic weight is 32 grams. Means one molecule of oxygen weighs 32 grams. Now how many particles are present? Avogadro number only 6.022 into 10 power 23. The difference is, here it is in molecule, then here also it becomes molecule. That is nothing but molecules of O2. If you consider one more example, one molecule of N2, nitrogen atomic weight is 14. Then 2 atoms, 28. So that is nothing but 28 grams. Means one molecule of nitrogen weighs 28 grams. Now, how many particles are present in that? Avogadro number 6.022 into 10 power 23. Here molecules is came, so here also it becomes molecules of nitrogen. So say one more example. One molecule of HCl, hydrochloric acid. Its molecular weight is 36.5 grams. What does it mean? It contains 6.022 into 10 power 23 molecules of HCl. molecules of HCl. If we consider in the case of ammonia, that is the formula is NH3. Now, what is the, if you consider, I am considering one molecule of ammonia, its molecule formula is NH3. Nitrogen 14, 3 hydrogen atoms are 3, so totally it is 17 grams. Means one molecule of ammonia weighs 17 grams, that contains 6.022 into 10 power 23 molecules of NH3. If we consider sulfuric acid, one molecule of H2SO4, its molecular weight is 98 grams, means 98 grams of sulfuric acid is considered as one molecule. How many molecules are there in that? Means the total number is 6.022 into 10 power 23 molecules of H2SO4. Here, in this case, what we can understand is, if the given concept is atom, after the Avogadro number, we should write the number of atoms. If it is molecule, we should consider the molecular weight, and after the Avogadro number, we should write the molecular weight of those compounds. For that sake only, that is called mole concept. Let us discuss some of the problems based on the mole concept, what is provided in our regular 9th class textbook. Of course, same kind of the model problems we can see even in CBSE textbook also.